lymphotoxin beta in germinal centers and even in infection. It started with Yang Sin Fu from Chicago came and gave a wonderful talk today about an infectious process that triggers the following sorts of response. A lymphotoxin inducer, lymphoid tissue inducer cell arrives into a lamina propria of the gut, and it produces lymphotoxin beta. That then, this is the critical part, lymphotoxin beta on the lymphoid tissue inducer cell. That does a lot of things, but one thing it does, it interacts with the stromal cell, and I believe the signaling is through a p52 pathway through the lymphotoxin beta receptor. And then it produces a couple of chemokines, I believe the CXCL1 and 2, that then act on neutrophils and bring them in. And if this pathway is interrupted, either by no lymphotoxin, no receptor, this does not occur. And interestingly, these cells produce RR gamma T and probably produce IL-22, some of the signature cytokines. So the whole idea is the following concept is lymphoid tissue inducer cells come in and they interact with stroma cells or other cells. And then that interaction supports this whole process and maybe brings down the cells. So let's go over here to a germinal center. We study a germinal center, BXC2 germinal center. And what happens is, let's start with a dendritic cell. This is a critical cell. And a dendritic cell is like the equivalent of the stromal cell. And the B cell, which is known to produce high levels of lymphotoxin beta, interestingly, the T cell, the role is less clear, but B cells produce lymphotoxin beta. Now in our case, we think the marginal zone precursor cell. So it's an early B cell, T1 or let's say T2, T3, but let's say the T3 or transitional T3 cell is the key cell. And we haven't tested this, but other people have. Probably produces the lymphotoxin beta. And it comes in, and we think it comes in under the influence of interferon alpha release from the marginal zone, or at least it gets trapped in there in the absence of interferon alpha signaling going in, or it gets locked in there with IL-17 signaling. But we have these models of how they get in there. But then what do? What's the main event? The main event might be that then they produce lymphotoxin beta. These are the MZPs, the B cells. And they act on dendritic cells. And then that induces CXCL13 from the dendritic cell, just like it does over here, which acts on CXCR5. Notice over here, it's on another part, but CXCR5 is a typical chemokine receptor that's expressed on a lymphoid tissue inducer cell. So that's what this is, really like a lymphoid tissue inducer cell. One other interesting thing is CXCR5 was also expressed on T follicular helper cells. But I think he said lymphotoxin beta is not essential for that interaction. So probably you don't want to put T follicular helper cells into the category of a lymphoid tissue inducer cell. But the B cell may be like that. Now another place where lymphoid tissue inducer cells has a role in the germinal center is back up here with the T cells interacting with stromal cells. Same thing here. These T cells, and it's not clear that they produce lymphotoxin beta, but let's say they do, and they might be RR gamma T positive. They do the same thing. Lymphotoxin beta acts on the stromal cells that signals through P52 pathway, and then that upregulates CXCL12 because that's probably the chemokine that's important, pulls the T cells into CXCR4. So it's a little different, up here if this is the case. And so the experiment will be to block lymphotoxin beta and see what happens. One thing that will happen is if you block lymphotoxin beta, you won't get down here with the B cells, you might not get CXCL13, you might not get a good germinal center, and the B cells may go away. Also, since this interaction, the lymphotoxin beta production by these MZPs, maybe through IL-17 receptor signaling, we talked about that a little bit, maybe that causes this FDC it's necessary for the maintenance of FDCs. So if you block it, the FDC may go away. If the FDC goes away, then the B cell goes away. So it'll be interesting to see which goes away first. It says it takes about 2 weeks for this to happen. So maybe in 1 week, the FDC goes away. 2 weeks, the B cells go away. Or maybe the other way around. And then at the same time, we can look at the T cells, the T cell zone, because they should be lymphoid tissue inducers. producing lymphotoxin beta, and then the stromal cells down here that have the LT beta receptor. Maybe the stromal cells go away, or maybe the T cells go away. So we really good to do this blocking experiment. And we can do also bone marrow transfer experiment. Radiate the mice, these cells will be the same, and transfer in lymphotoxin knockout B cells or T cells. So in summary, I think that this is going to be a new avenue for research for IL-17 signaling, which could upregulate lymphotoxin expression on these lymphotoxin inducer cells, and to expand the concept of what a lymphotoxin inducer, a lymphoid tissue inducer cell is. It's really an MZP-B cell, or B cells. It might be a T cell interacting with the stromal cell. So this is very critical for understanding early B cell development, germinal center development, and how autoreactive germinal centers develop in DXD2 mice.